Audible or not? Please confirm my voice is audible. Just confirm whether my voice is audible or not. Am I audible to you? Okay, so a very good evening everyone. Myself Prateek Mishra and I welcome to the YouTube platform of IMS GATE Academy. We are conducting this series for most expected concept for GATE-24 for the subject of environmental engineering, which is again a highly weighted subject. We discussed about the concept of sedimentation analysis yesterday, and today we will going to see a very important topic, that is disinfection. Okay, we are talking about raw water treatment. So my dear students, yesterday itself I have told you that the degree of treatment given to the raw water depends upon the existing quality of the raw water and the desired quality of the treated water. Depending on the existing quality of raw water, different degrees of treatment are given to this. Okay. We started the first method by which we treat the water is known as screening. Screening basically removes all the suspended solids, coarse suspended solids. So when I talk about raw water treatment, the first is screening, which removes coarse suspended solids. Then second mechanism is aeration. Aeration basically removes all the dissolved gases, it removes organic matter, it removes color causing compounds, it also removes taste and odor, right? So aeration removes a lot of things. After this, we go for softening, which removes hardness from the water. Then we have coagulation and flocculation. Basically, this coagulation and flocculation is done to agglomerate the fine suspended solids to form a larger size of particle. Through coagulation and flocculation, once we start getting these larger size of particle, these larger size of particles are settled out in the sedimentation tank. So after coagulation and flocculation, next treatment given to water is sedimentation. After sedimentation, we go for filtration. So basically, filtration removes all the fine suspended solids that are present in your water sample. After filtration, the last treatment given to the water is termed as disinfection. The last treatment which is given to the water is disinfection. The last treatment which is given to the water is termed as disinfection. Okay. We want to consume this water for day-to-day usages, okay, and we want this water to free from all the disease-causing microorganisms. That's why we give disinfection to water. We do disinfection to this water. Disinfection is the process through which we remove all the disease-causing microorganisms that are present in our water sample, okay. Whatever water we consume, this water should be free from pathogens that are disease-causing compounds. And the technique which is used to remove all these disease-causing compounds from the water sample is termed as disinfection. Now you have to understand this very carefully. Once you have extracted water from the source, right, this water will contain microorganisms. So we treat this water and we disinfect this water inside the water treatment plant. Okay, we remove all the disease-causing microorganisms inside the water treatment plant. Now when this water moves out from the water treatment plant and it is distributed in the community, during this time of distribution, there are chances that due to some leakages, again these microorganisms can add up into this water. So we need to take care of two things. First one is we need to disinfect this water which we have extracted from the source, and second is we need to take care of this future recontamination. So whenever we do any method of disinfection, we do it for treating water right now, for disinfecting water at the water treatment plant, and we add some extra chemicals so that this future recontamination can also be taken care. Okay. So disinfection is a very simple mechanism of killing all the disease causing microorganisms. Now here one statement can be framed, and that statement can be, what is the difference between disinfection and sterilization? What is the difference between disinfection and sterilization? A statement can be framed, right, for a multiple select question using these two words. Most of us basically use these words without thinking that there is any difference, but there is a slightest difference between disinfection and sterilization. Okay. The killing of only disease causing microorganisms is termed as disinfection. Disinfection is killing of disease causing microorganisms. These disease causing microorganisms are known as pathogens. So basically disinfection is the mechanism of killing pathogens that are present in our water sample. Okay. What does sterilization means? Sterilization means killing of all the type of microorganisms, whether they are disease causing or non-disease causing, it doesn't matter. If we are killing all the microorganisms that are present in our water sample, it is termed as sterilization. So sterilization is killing of all the microorganisms that are present in the water sample. These microorganisms can be disease causing, or they can be harmless microorganisms. So the method of killing all the type of microorganisms that are present in our water sample is termed as sterilization, right? Now where do we see sterilization? So basically whenever we visit any dentist, all these dentists have a unit or have a compartment in which they keep their equipments, right? That compartment is the sterilization unit. Earlier we used to have these huge cylindrical tanks in which all these medical equipments are placed, and the pressure is raised inside this cylinder, due to which temperature also increases, and due to this high temperature, all the microorganisms that are present inside this sterilization unit get kills. Okay. So there are two things. First one is disinfection, which is killing of only disease causing microorganisms. Second one is sterilization, which is killing of all the type of microorganisms, which can be disease causing or non-disease causing. Okay. Now while we were reading about biological water quality parameters, I have told you that disease causing microorganisms are known as pathogens, whereas non-disease causing microorganisms are, the example being E. coli or Escherichia coli or coliforms. So these harmless microorganisms can be coliforms. So killing of pathogens and coliforms are just one of the examples, so that you can remember that coliforms are non-disease causing microorganisms. There can be other examples also. killing of all the type of microorganisms present in the water is termed as sterilization. But while treating water, we are only interested in killing of pathogens. That is why we disinfect this water. Now, this disinfection can be done using any of the following methods. There can be physical methods of disinfection. The first physical method is by simply boiling the water sample. Second physical method is UV treatment or ultraviolet rays. Ultraviolet rays treatment or UV treatment. Okay. So, the disinfection can be carried out either using physical methods. Very good evening, Richa. Disinfection can be carried out either using physical methods or it can be carried out using chemical methods. For physical method, the first method is boiling, second is UV treatment. For case of chemical methods, the first treatment is by the use of alkalis and acid. Second is by the use of metallic ions. These metallic ions can be silver, it can be silver, gold or copper. So, whenever you see these ancient things that are there or kitchenware that you see that are from the early ages, right? Most of these things are made up of copper, and if you see the royal set of this kitchen, right, most of them are made up of silver. The reason is silver, gold and copper are a very strong disinfecting agents, right? They disinfect the water that is there. So, they kill all the pathogens that are present. The third chemical method is by the use of oxidizing agent. That is by the use of chlorine, bromine, iodine, then you have KMNO4, then you have hydrogen peroxide, then you have ozone, O3, right? All these are the chemical methods of disinfecting the water, right? So, disinfection can be carried out either through physical methods or through chemical methods. Through physical method, there are two methods for disinfection. First one is by boiling, second is by UV treatment. For chemical method of disinfection, you can either go with the treatment with alkalis or acid, or you can go with the treatment with metallic ions, and third one is treatment with your oxidizing agents, right? So, these are the different methods of carrying out the disinfection. Now, for us, only three methods are important from the exam point of view. So, the next topic of discussion is minor methods of disinfection. The first minor method of disinfection is treatment with ozone. First minor method of disinfection is treatment with ozone. This is simple, right? Now we know that ozone is O3 and this O3 minus ion contains nascent oxygen. And this nascent oxygen is a very strong oxidizing agent. This is a very strong oxidizing agent. It's a strong oxidizing agent. So, when this nascent oxygen comes in contact with the microorganisms, if this is my microorganisms, right, you can remember the class 10th of biology where you have drawn microorganisms and different parts of microorganisms. So, we do not require that much detail, but just one detail. Every microorganism has the cell wall around it, okay. This is the cell wall that is present around the microorganism. And we know that this cell wall is nothing but the organic matter. This nascent oxygen which is present in the ozone destroys the cell wall of this microorganisms, due to which the essential fluids that are present inside the microorganism which are required for its metabolism, these fluids just flow out and leads to the killing of microorganisms. This nascent oxygen destroys the cell wall. This nascent oxygen which is present in the ozone destroys the cell wall and leads to the killing of microorganisms. So I'll write down the nascent oxygen or O3, ozone, destroys the cell wall and leads to the killing of microorganisms. And leads to the killing of microorganisms. So the first minor method of treatment is treatment with ozone. Very good evening, Nikhil sir. Very good evening. So the first minor method of disinfection is treatment with ozone. Okay. Ozone has a nascent oxygen which is a very strong oxidizing agent. This nascent oxygen destroys the cell wall of the microorganisms. This is the cell wall of microorganisms, and which leads to the killing of microorganisms. And this is how ozone carries out the disinfection in water sample. Now when you add ozone, it imparts pleasant taste to water. It imparts pleasant taste to water. It imparts pleasant taste to water. But on the other hand, treatment with ozone is very costly. That's why we do not prefer treating the community water through ozone. The second reason why we do not prefer treatment of community water with ozone is highly reactive. As the time you add ozone, within no time, this ozone will carry out the oxidation and get exhausted, right? So ozone can right now treat the water, but the same ozone cannot take care of the future recontamination, because as you just add this ozone, entire ozone will react and will get exhausted from the water, right? So this ozone cannot take care of the future recontamination. Ozone being highly reactive, cannot take care of future recontamination. So this is the problem with ozone, right? Ozone treatment is very costly. No doubt efficiency of ozone is less than the efficiency of disinfection by chlorine. Third reason is ozone get exhausted and it cannot take care of the future recontamination. So this is the first method of disinfection, and this is the minor method. This is not used to treat community water. It is only used to treat water for private use or for industrial use, right? So the first minor method of disinfection is treatment with ozone. Ozone has this nascent oxygen which is a strong oxidizing agent. Ozone destroys the cell wall of the microorganisms, hence leads to the killing of microorganisms. Ozone imparts pleasant taste to water. Next, efficiency of disinfection of ozone is less than the efficiency of disinfection with chlorine, right? Next, ozone is costly than chlorine. And last one is ozone gets exhausted as the time we add ozone for disinfection. That's why ozone cannot take care of the future recontamination. Okay. So this is the first minor method of disinfection, that is treatment with ozone. Now next minor method of disinfection is treatment with KMNO4. Treatment with KMNO4. This treatment technique or this disinfection technique you will mostly see in villages, right? Where these wells are the only source of water. So these village people, what they do is, or the people from small community which are depending on this underground source from wells, they add KMNO4. KMNO4 is a pink substance. They add KMNO4 for disinfection and they leave this water for 48 hours. Okay. They add KMNO4 in the wells and they leave this water for 48 hours. Now this KMNO4 is again a very strong oxidizing agent. What this KMNO4 does is, this is my cell wall of microorganisms. Okay. Now as our skin has pores from where sweating happens, same pores are present in the cell wall of microorganisms. This KMNO4 increases the permeability of these pores, due to which all the fluid that is required for the life of the microorganisms, it flows out. What KMNO4 does? It increases the permeability of the cell wall, due to which the essential fluid which is required for the life of microorganism, it flows out and leads to the killing of microorganisms. So KMNO4, I'll write here, KMNO4 increases the permeability of cell walls, due to which essential fluid required or essential fluid flows out, leading to the killing of microorganisms. Leading to the killing of pathogens. Leading to the killing of pathogens, right? KMNO4 is pink. KMNO4 is pink in color. So after placing KMNO4 in wells, water is left for 48 hours. And in this 48 hours, KMNO4 will carry out the disinfection of the pathogens that are present in water, right? KMNO4 is basically used to treat village waters or water from wells, right? Again, KMNO4 is not used for the treating of community water. So these two minor methods of treatment are used to treat water at small scale, okay? They are not used to treat community water. Now, in order to treat community water, the method that we use is chlorination. So please give the next heading, treatment or major method of disinfection, which is treatment with chlorine. Major method of disinfection that is treatment with chlorine. That is treatment with chlorine, right? Now this is the widest method that is used. Across the country, in India, we disinfect the water using chlorination. There are two reasons. First one is, it is available in all the three forms, solid, liquid and gas. Second, its storage is easy, right? It can be stored for longer duration. Third, it does not form any sludge after carrying out the disinfection. Now see, how does treatment with chlorine happens? When you add chlorine to water, at pH more than 5, chlorine reacts with water to form hypochlorous acid. Chlorine reacts with water to form hypochlorous acid. This is hypochlorous acid. When you add chlorine to water, chlorine reacts with water to form hypochlorous acid. Now this hypochlorous acid, HOCl, this hypochlorous acid, if the pH of the water sample is more than 8, this hypochlorous acid dissociates into hypochlorite ion, OCl minus, and H plus ion. So this is your hypochlorite ion. This is your hypochlorite ion, right? If the pH of the water sample is less than 7, then this dissociation will go backward. That is, only hypochlorous acid will stay in the system, right? When you add chlorine to the water at pH more than 5, this chlorine reacts with water to form hypochlorous acid. Second, when the pH of the water sample is more than 8, this hypochlorous acid dissociates into hypochlorite ion, but if the pH is less than 7, this dissociation goes backwards and you will see more amount of hypochlorous acid formed in the system. Now when you observe this chlorine, Cl2, hypochlorous acid, HOCl, I'll write here, this hypochlorous acid, HOCl, and hypochlorite ion, OCl minus, all these three compounds carry out the disinfection in water sample. These three forms of chlorine, Cl2, HOCl and OCl minus ion, are known as freely available forms of chlorine. Cl2, HOCl and OCl minus ion. Free chlorine, hypochlorous acid and hypochlorite ion. All these three are known as freely available forms of chlorine. Freely available form of chlorine. Freely available form of chlorine. All these three carry out the disinfection. 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 Now these three available forms of chlorine are available at different pH. If pH of the water sample is less than 5, if it is less than 5, then you will see free chlorine, Cl2. If pH of the water sample is between 5 to 7, if pH of the water sample is between 5 to 7, you will see hypochlorite ion, HOCl, hypochlorous acid. If pH of the water sample is between 7 to 8, if pH of the water sample is between 7 to 8, you will have both hypochlorous acid and hypochlorite ion, OCl minus. And if pH of the water sample is more than 8, your water sample contains more of hypochlorite ion, right? The three forms of chlorine that are available to carry out the disinfection are Cl2, HOCl and OCl minus. These three forms of chlorine are known as freely available chlorine or free forms of chlorine. All these three carry out the disinfection, but they are available at different pH. If pH of the water sample is less than 5, then free chlorine is available, Cl2. If pH is between 5 to 7, then hypochlorous acid will be available. If pH of the water sample is between 7 to 8, then hypochlorous acid and hypochlorite ion will be there. And if the pH of the water sample is more than 8, then only hypochlorite ion will be there. Out of these three freely available forms of chlorine, hypochlorous acid is highly destructible disinfectant. Out of all these three forms of chlorine, HOCl is the most destructive disinfectant. HOCl is the most destructive disinfectant. That is Cl2, HOCl and OCl minus ion. Out of these three forms of chlorine, HOCl carries out most destructive disinfection. Means rate of disinfection and the efficiency of disinfection for HOCl is the highest. Now you just observe this pH and tell me, if HOCl is the most destructive disinfectant, then we want our disinfection to be carried out by this HOCl. So during disinfection, the pH of the water sample is kept between 5 to 7, where majority of HOCl you will get. Hypochlorous acid will be there in majority if the pH of the water sample is between 5 to 7, right? Now this type of again multiple select question can be framed, or statement can be framed, that the most favorable pH for carrying out the disinfection. So four options will be there to you. You have to select that option where the pH range is between 5 to 7. Reason is, at pH of 5 to 7, hypochlorous acid will be predominating in the water sample, due to which most destructive disinfection can be carried out by this hypochlorous acid, right? So the favorable pH for carrying out the disinfection is 5 to 7. It is preferred to carry out disinfection at a pH range of 5 to 7. At a pH range of 5 to 7, right? Now next is how this chlorination carries out disinfection, or how this chlorine or freely available forms of chlorine carry out the disinfection. Basically, chlorine destroys the enzymes which are responsible for the metabolism of microorganisms, which leads to the killing of microorganisms. So chlorine freely available chlorine, hypochlorous acid, hypochlorite ion, all these destroys the enzymes which are responsible for the metabolism of microorganisms. So, chlorine, or you write down like this, chlorine destroys the enzymes required for the metabolism of microorganisms and leads to the killing of microorganisms. Leads to the killing of microorganisms. Leads to the killing of microorganisms, right? So, how chlorine carries out the disinfection? Chlorine destroys the enzymes which are required for the metabolism of microorganisms, hence leads to the killing of microorganisms, right? Now, when you add chlorine to the water, the first thing that will form is freely available forms of chlorine, that is Cl2, HOCl and OCl minus. This chlorine also reacts with the ammonia present in the organic matter which is there in the water sample. Chlorine reacts with ammonia present in the organic matter Chlorine also reacts with the ammonia which is present in the organic matter to form chloramines. So, Cl2, it reacts with NH3 to give NH2Cl. This is known as monochloramine. Monochloramine. Now, this NH2Cl this chlorine reacts with monochloramine to form dichloramine, NHCl2. This is dichloramine. This is dichloramine. Then again it reacts with dichloramine to form nitrogen trichloride. This is nitrogen trichloride. Okay. So, there are two things done by chlorine. The first thing is chlorine reacts with water to form freely available forms of chlorine. Second, chlorine reacts with the ammonia present in the organic matter to form chloramines. These chloramines NH2Cl, NHCl2 and NCl3, these chloramines are known as combined forms of chlorine. These chloramines are known as combined forms of chlorine. So, this is NHCl, NH2Cl, then you have NHCl2 and then you have NCl3. These are known as combined forms of chlorine. Combined forms of chlorine. And they are combinedly known as chloramines. Now these chloramines are also capable of carrying out the disinfection, but the efficiency of disinfection is less than the freely available forms of chlorine. So these chloramines also carry out the disinfection, but they are less destructive disinfectant. They are less destructive disinfectant than free forms of chlorine. They are less effective or less destructive disinfectant than free forms of chlorine, right? So when you are adding chlorine to the water sample, first of all, chlorine is forming free forms of chlorine. Next, chlorine is combining with the ammonia present in the organic matter to form chloramines. These chloramines are less destructive disinfectant, although they can carry out the disinfection that is there for the water sample, right? So whenever you are adding chlorine, there are 6 forms through which chlorine is carrying out the disinfection. The first 3 forms, that is Cl2, HOCl and OCl minus ion, they are known as free forms of chlorine. The next 3 forms, that is NH2Cl, monochloramine, dichloramine and nitrogen trichloride, all these are known as chloramines and they are less effective disinfectant as compared to freely available forms of chlorine. So when you are adding chlorine, the form which carries out the most destructive disinfection is hypochlorous acid, HOCl. Okay. So these are the different forms of chlorine that are present in the water sample once you add chlorine to the water sample. Now different forms in which chlorine can be added is different forms in which chlorine can be added. The different forms in which chlorine can be added to carry out the disinfection includes, first one is free chlorine. The different forms in which chlorine can be added to carry out the disinfection. The first one is free chlorine. Free chlorine, Cl2, it is available in all the 3 forms. It is available in all the 3 forms. Free chlorines are available in all 3 forms, that is solid, liquid and gas. Free chlorine is available in all the 3 forms, that is solid, liquid and gas. This free chlorine is highly temperature sensitive. They are highly temperature sensitive. Means they freeze at temperature below 10 degrees Celsius. They freeze at temperature less than 10 degrees Celsius. And they burst the container. They burst the container of storage. They burst the container of storage above temperature of 92 degrees Celsius. Okay. This is the reason, that is they freeze at temperature less than 10 degrees Celsius. This is the reason why free chlorine is not used as a disinfectant for cold countries like European countries. European countries, they majorly carry out the disinfection using UV ray treatment. Some of them even use ozone for treatment of raw water, right? Since the temperature of these European countries are on the means colder side, it is less than 10 degrees Celsius. So if they start using chlorine, this chlorine is liable to freeze while supplying it for water treatment. That's why they do not go with chlorination for disinfecting their raw water, right? In India, we have a moderate temperature range, right? It is means in most of the part of the country, the temperature is above 10 degrees Celsius throughout the year, and it is even less than 50 degrees Celsius throughout the year, right? So there is no point of bursting the container by chlorine or chlorine getting freezed. Although in some mountain areas where the temperature is really less than 5 degrees Celsius, there we go for other methods of treatment, right? So this is the first form of chlorine, that is free chlorine, how you can add this chlorine to the water. So free chlorine is available in all the three forms. It is highly temperature sensitive. It freezes at temperature less than 10 degrees Celsius, and it burns the container or bursts the container if its temperature is more than 92 degrees Celsius, right? It can be stored for longer duration. It can be stored for longer duration. It can be stored for longer duration. The only drawback is this chlorine forms the explosive mixture when it comes in contact with carbon monoxide. It forms an explosive mixture. It forms an explosive mixture with carbon monoxide, CO. It forms an explosive mixture with carbon monoxide. In majority, this is the form in which we add chlorine to the water sample, that is free chlorine. Now the next form in which we can add chlorine to the water sample is in the form of hypochlorite ion. So the next form in which we can add chlorine is in the form of hypochlorite ion, that is NaOCl, that is in the form of hypochlorite ion, that is CaOCl2, or bleaching powder. CaOCl2, right? Now in the examination, there can be a question that what is the disinfection efficiency for hypochlorite ion or for the bleaching powder. So how you should deal with it? You should start with CaOCl2, OCl2. Gives 2 moles of OCl minus ion. So 1 mole of CaOCl2 gives 2 moles of OCl minus ion, right? You can just calculate the molecular weight of CaOCl2. So calcium is 40, oxygen is 16, chlorine is 35.5 into 2. This is the weight in grams of this CaOCl2, and this much weight of CaOCl2 will give 2 moles of OCl minus ion, which is 16 plus 35.5. Okay, this is also in grams. Now for calculating the disinfection efficiency for CaOCl2, so efficiency of disinfection for CaOCl2 is equal to weight of OCl minus ion that is present in CaOCl2. So this is 2 times of 16 plus 35.5 divided by 40 plus 2 times of 16 plus 35.5 into 100. So disinfection efficiency, when you calculate this, you will find that the disinfection efficiency for CaOCl2 will be 70%. This efficiency of disinfection for CaOCl2 will come out approximately to be 70%. Will come out approximately to 70%, right? Now this type of questions can be asked in your examination. Whenever such type of question is asked that what is the disinfection efficiency for a particular disinfectant, only you need to check here OCl minus ion will carry out the disinfection. So what is the percentage of OCl minus ion that are present in CaOCl2? Like that you calculate the efficiency of disinfection. Okay, this is again a variety of question can be asked. The next form in which chlorine can be added is through chloramines. You can directly add chloramines in water to carry out the disinfection. You can directly add chloramines. The next is chlorine dioxide. Chlorine dioxide, ClO2. Now this chlorine dioxide is the most destructive disinfectant. It is most destructive disinfectant. It is like 25 times more destructive. It is 25 times more destructive than freely available forms of chlorine. Then freely available forms of chlorine. It is 25 times more destructive than freely available forms of chlorine. So if a question is asked in your examination related to what is the most destructive form of chlorine that can carry out the disinfection, and if this option is given to you, you mark this chlorine dioxide. But if it is asked that what is the most destructive free form of chlorine, so you will mark hypochlorous acid, HOCl. But overall ClO2, that is chlorine dioxide, is the most destructive form of chlorine, right? So these are the 4 forms in which we can add chlorine to the water to carry out the disinfection. Either we can add in the form of free chlorine, we can add in the form of hypochlorite ion or bleaching powder. The third form in which we can add chlorine is through chloramines. The fourth form in which we can add chlorine is chlorine dioxide, Cl2. But again this ClO2, ClO2 is a very strong oxidizing agent. It is highly reactive. So this ClO2 cannot take care of the future recontamination. So ClO2 is highly reactive. Hence, it cannot take care of future recontamination. Hence, it cannot take care of future recontamination, right? So this is the theory part of disinfection which is required, because a lot of statements can be framed from this theory part. Now coming to the next topic of discussion, which is kinetics of disinfection. The next topic of discussion is kinetics of disinfection. How the disinfection is carried out, all those things we will going to discuss now. Next topic of discussion is kinetics of disinfection, right? Here we will going to discuss how the microorganisms are getting killed when we are adding chlorine as a disinfectant. So kinetics of or disinfection follows first order kinetics. Disinfection follows first order kinetics. It means the rate of killing of microorganisms dNt by dt, the rate of killing of microorganisms is directly proportional to the number of microorganisms present at any time t. More the number of microorganisms, more will be the rate of disinfection. Less the number of microorganisms, lesser will be the rate of disinfection. So the rate of disinfection minus dNt by dt, this minus sign is there because this number of microorganisms are reducing, they are getting killed. So minus dNt by dt, that is the rate of disinfection or the rate of killing of microorganisms. This is the rate of killing of microorganisms or rate of disinfection. Rate of disinfection is directly proportional to the number of microorganisms present at any time. These are the number of microorganisms present at any time. Present at any time t, right? So the rate of disinfection, that is the rate of killing of microorganisms, is directly proportional to the number of microorganisms that are present at any time t, which is equal to nt. Okay. Now we will just solve this. So minus dNt by dt is equal to k times of nt. So when you solve this, you have to just rearrange this. So minus dNt by nt is equal to k into dt. You take minus sign this side. So you have dNt by dt is equal to minus k into dt. Now integrate this expression. So on integrating at time t is equals to 0, the number of microorganisms that are present are n naught. At any time t, the number of microorganisms that are present in the system is nt. At time t is equals to 0, the number of microorganisms present are n naught. And after disinfection for some time t, the number of microorganisms present are nt. So just integrate this. So you have natural log of nt by n naught is equal to minus k into t. Just rearrange this, take the nt log. So you have one expression which is known as nt is equal to n naught into e raised to power minus k into t. This expression is known as Chick's law. This expression is known as Chick's law. This expression is known as Chick's law, where NT is the number of microorganisms present after time t. Where NT is number of microorganisms present after time t. N naught is number of microorganisms present initially, that is at time t is equals to 0. At time t is equals to 0, the number of microorganisms that are present in the system is N naught. T is known as disinfection constant. Sorry, K is known as the constant of disinfection and T is the time. T is the time. When you plot the rate of change of microorganisms, so on the y-axis, I have plotted number of microorganisms, and on the x-axis, I have plotted time. So at time t is equals to 0, the number of microorganisms present are N naught. And these number of microorganisms will keep on decreasing like this, right? So at any time t, this is any time t, the number of microorganisms that are present, these number of microorganisms that are present at any time t is Nt. The number of microorganisms which are present at any time t is Nt, right? So this is how the number of microorganisms keep on decreasing when disinfection is happening. Okay, so from this Chick's law, again, a lot of numericals are formed. So you can check on this Chick's law, which is a very simple law. Nt, which is the number of microorganisms present at time t, and N naught is the initially number of microorganisms present. So Nt is equals to N naught e raised to power minus K into T, where K is the constant of disinfection and T is the time. Okay. So this is the kinetics of disinfection. Moving on with this, the next topic of discussion is types of chlorination. Types of chlorination. The next topic of discussion is types of chlorination. The first type of chlorination is known as plain chlorination. The first type of chlorination is known as plain chlorination. If you take the water sample and you only do the chlorination, that is known as plain chlorination. So if chlorination or the disinfection is the only treatment given to the water, it is known as plain chlorination. So if chlorination is the only treatment given to water. If chlorination is the only treatment given to water, then it is known as plain chlorination. Next is known as pre-chlorination. The next type of chlorination is known as pre-chlorination. The next type of chlorination is known as pre-chlorination. So, before coagulation and flocculation or along coagulation and flocculation, if you do chlorination, it is known as pre-chlorination. So, if chlorination is given, before coagulation and flocculation, if chlorination is given before coagulation and flocculation, it is termed as pre-chlorination. The third variety of chlorination is post-chlorination. The third variety of chlorination is post-chlorination. The third variety of chlorination is post-chlorination. If chlorination is the last treatment given to water, then it is known as post-chlorination. If chlorination is the last treatment given to water, then it is known as post-chlorination. Now, the next type of chlorination is known as double chlorination. The next type of chlorination is double chlorination. Now, for treatment, when you have this more dirty water, right, especially during rainy seasons, for this water, in order to improve the efficiency of disinfection, if you give both pre-treatment, if you give both pre-chlorination and post-chlorination, just to increase the efficiency of disinfection, it is known as double chlorination. So, if pre and post chlorination both are given to the water for increasing the efficiency of disinfection, it is known as double chlorination. So, if pre-chlorination and post-chlorination are given to water, for increasing the efficiency of disinfection, then it is known as double chlorination, right? So, there are 4 different types of chlorination. First one is the plain chlorination. If chlorination is the only treatment given to water, we do not give any other treatment, then this type of chlorination is known as plain chlorination. Second, if chlorination is given before coagulation and flocculation, then it is known as pre-chlorination. If chlorination is the last treatment given to the water, it is known as post-chlorination. If you simultaneously give pre-chlorination and post-chlorination in order to increase the efficiency of disinfection, it is known as double chlorination. Next type of chlorination is the most important chlorination, which is known as breakpoint chlorination. Which is known as breakpoint chlorination. Which is known as the breakpoint chlorination. This is the most important part of your entire disinfection. So please mark it. Please mark this. So next topic of discussion is breakpoint chlorination. Before beginning this breakpoint chlorination, you need to know few things about chlorine. Then only you can understand this. First one is, when you add chlorine to water, chlorine will form free forms of chlorine, and chlorine will also combine with ammonia present in the organic matter to form chloramines. So simultaneously, when you add chlorine, you have two different forms of chlorine available: free forms of chlorine and combined forms of chlorine, which are known as chloramines. All the 6 forms of chlorine carries out the disinfection. On the other hand, chlorine is also a strong oxidizing agent, right? Chlorine is a strong oxidizing agent. Now please look into this. So chlorine, when added in water, so chlorine is a strong oxidizing agent. Chlorine is a strong oxidizing agent. Due to the oxidizing nature of chlorine, the first thing that chlorine does is it oxidizes inorganic compounds. It oxidizes inorganic compounds. It oxidizes inorganic compounds like iron and manganese, which are color causing compounds. It oxidizes inorganic compound. The second thing that chlorine does is it oxidizes organic compound. It oxidizes organic compound. It oxidizes organic compound. And the third thing that chlorine does is it carries out the disinfection of microorganisms. That is, killing of microorganisms. Killing of microorganisms. So whatever chlorine you are adding to your water sample, it is simultaneously carrying out the oxidation of inorganic compounds, oxidation of organic compounds, and the killing of microorganisms. So chlorine is not only used for the killing of microorganism, some part of chlorine is also getting wasted to carry out the oxidation of inorganic and organic compounds. Okay. Now chlorine demand, which is required to treat water or disinfect water, can be calculated as chlorine demand is equal to applied chlorine, means whatever chlorine you have added from your side, chlorine demand is equal to applied chlorine minus residual chlorine. So chlorine demand, that is the amount of chlorine which is required to carry out the disinfection, it depends on two things: how much chlorine you are applying, and second, how much chlorine is left after this disinfection is done, right? So chlorine being a strong oxidizing agent will oxidize the inorganic compound, will oxidize the organic compound, and will be used for killing of microorganisms. So this is the domain where all your chlorine is getting used up. And the amount of chlorine required to do all these activities is known as chlorine demand, right? Because when we are adding chlorine for all these activities, we are actually adding total amount of chlorine that is required to carry out the disinfection. So chlorine demand is equal to applied chlorine minus residual chlorine. Applied chlorine is the chlorine that you have added from your side. Residual chlorine is the leftover chlorine which is left after oxidation of inorganic compound is done, oxidation of organic compound is done, and killing of microorganisms are done. So this residual chlorine is nothing but the leftover chlorine. Leftover chlorine. They are the leftover chlorine, right? Now just see this. On the y-axis, I have plotted residual chlorine and on the x-axis, I have plotted chlorine dose. This is chlorine dose in milligram per liter, right? On the y-axis, I have plotted residual chlorine and on the x-axis is the chlorine dose. Now just imagine one water sample which does not contain anything. Neither it contains inorganic compound, neither it contains organic compound, neither it contains microorganisms. Just imagine that. So whatever chlorine dose you will apply, the entire chlorine dose will be converted into residual chlorine. If nothing is present in your water sample, neither inorganic compounds are present, nor organic compounds are present, nor your microorganisms are present, then whatever chlorine dose you will apply, all that will be converted into residual chlorine. No chlorine dose will be used. So in that case, the plot will be like this. This is the kind of plot that you will get. This is the kind of plot that you will get. This is the kind of plot that you will get, right? Whatever chlorine dose you are applying, that chlorine dose is directly converting into residual chlorine. So this angle will come out to be 45 degrees. And this line is known as zero chlorine demand line. This is known as zero chlorine demand line. This is known as zero chlorine demand line. This line will tell us that if no inorganic matter is present, no organic matter is present, and no microorganisms are present, then whatever chlorine dose you will apply, that entire chlorine dose will be converted into residual chlorine. And what is residual chlorine? It is the leftover chlorine that we have once chlorine does all its operation. That is carrying out the oxidation of inorganic compounds, carrying out the oxidation of organic compounds, and carrying out the killing of microorganisms, right? So this is the ideal case. This is known as zero chlorine demand line. Angle is 45 degrees. Now imagine your water sample contains all the inorganic compounds, organic compounds, and also your microorganisms, okay? When you start adding chlorine, initially all the chlorine will be used up by the, to carry out the disinfection. Initially all the chlorine will be used up to carry out the oxidation of inorganic compounds. When all the three compounds are present in your water sample, inorganic matter, organic matter, and microorganisms, then when you add chlorine, all the chlorine will be used up to carry out the oxidation of inorganic compound. After that, after this point, when oxidation of inorganic compound is done, now this chlorine will react with organic matter to form chloramines. Beyond this point, chlorine will react with water to form chloramines. Beyond this point, the chlorine will react with water to form chloramines, right? Now, when I talk about the rate or the rate of disinfection of chloramines, the rate of disinfection of chloramine is less than the freely forms of chlorine. They take some time to carry out the disinfection. They do not readily carry out the disinfection. They stay some time in the water sample before carrying out the disinfection. So, this is the time when more and more chloramines are getting formed and you get more value of residual chlorine. The value of residual chlorine keeps on increasing like this. So, this graph is right now divided into two major areas. First area is where you are getting the first major area is where the oxidation of inorganic compounds are taking place. This is the first phase of your graph. This is the phase 1, right? Then you have the second phase of your curve where chloramines are getting formed and you are seeing more quantity of residual chlorine that is getting formed, right? Now, beyond this point, these chloramines that are formed in the system, now they start carrying out the decomposition of the organic matter, and the value or the quantity of these chloramines keep on reducing. Here, continuous chloramines are getting formed, that's why the quantity of residual chlorine keeps on increasing. But beyond this point, these chloramines now carry out the disinfection and they get used up. So, you will see reduction in the residual chlorine because these chloramine are now carrying out the disinfection and the value of these chloramines are getting used up. So, residual chlorine will decrease. At this point, all the microorganisms are killed, right? At this point, all the microorganisms are killed, all the inorganic matter is oxidized, all the organic matter is oxidized. Now, this much amount of chlorine which is left in the system at this point, this much amount of chlorine which is left in the system at this point. So, this point is known as the break point, and this much amount of residual chlorine which is left in the system, it is known as combined residue. This is known as combined residue. So, I will start from here. This is O, this is A, this is B, this is C, and C is known as break point. C is known as break point. C is known as the break point, which tells us about that all the microorganisms that are present in the system, all the microorganisms are killed, all the inorganic matter is oxidized, all the organic matter is oxidized. Now, this much amount of residual chlorine which is left at point C is known as combined residue. And beyond this point, if you add any dose of chlorine, that dose will be directly converted into residue. Beyond this break point, if you add any dose of chlorine, that will be converted directly into residue, and this kind of increase in residue you will see beyond the break point. And this angle is again 45 degrees, because at break point situation is again same as that of zero chlorine demand line. At breakpoint, all the microorganisms are killed, all the inorganic matter is removed, all the organic matter is removed. Now your water is free from all the three things. So whatever chlorine now you will add, that will be directly converted into the residual chlorine. So if you take anything like this, right? So if you take like this is known as free residue and this one is known as combined residue. This part is known as combined residue and this part is known as free residue. This is known as free residue. Because this is the amount of chlorine that you have added beyond the break point. This free residue is nothing but this amount of chlorine that you have added after the break point. This is the amount of chlorine that you have added after the break point, and this much amount of chlorine will be directly present in the form of free residue because this chlorine has nothing to react with. There is no organic matter present so that this chlorine can react. There are no microorganisms present so that this chlorine can carry out disinfection. Neither any inorganic matter is present so that this chlorine can carry out the oxidation of that, right? So this type of chlorination is known as breakpoint chlorination. So this is my phase 2. This is phase 3. And this is phase 4. So in phase 1, what is happening? In phase 1, oxidation of inorganic matter is taking place. In phase 2, formation of chloramines are taking place. In phase 3, these chloramines are getting oxidized, these chloramines are carrying out the disinfection, hence their quantity is getting used up. At point C, which is the break point, all the microorganisms are getting killed. All the inorganic matter is oxidized, all the organic matter is oxidized. Beyond the break point, if you add any chlorine, that chlorine will be directly stored in the form of free residue. At break point, the amount of residual chlorine is known as combined residue because this is the amount of chloramines that are left in the system. Now, one of the favorite question is asked in the examination regarding in which section disinfection is taking place. So you have to be very, very careful in answering this. As the moment you have added chlorine, the free forms of chlorine will carry out the disinfection from this point till this point. But chloramines that are formed in the system, they carry out the disinfection beyond point B, that is in phase 3. Chloramines will only carry out the disinfection in phase 3. But free forms of chlorine will carry out the disinfection at the moment from where you have added this chlorine to your water sample, right? So this is a very, very important curve. I hope you have understood this. So I'll write down in stage 1 or phase 1, oxidation of inorganic compounds in stage 2, formation of chloramines, in stage 3, chloramines carrying out the disinfection carrying out the disinfection. Then you have point C, which is known as the break point. Point C, which is known as the break point. And beyond break point, whatever chlorine dose you are adding, that chlorine dose is getting converted into free residue. Now, I was talking about this future recontamination, right? You can clearly see even at the break point, when all the microorganisms are killed, some amount of chlorine in the form of combined residue is still left with the water sample. Now, this combined residue is left intentionally. It is not removed. Reason is, when we supply this water through water distribution system, and if any future recontamination will happen, that future recontamination will be taken care by this combined residue. This combined residue will carry out the disinfection if any future recontamination happens to water. That's why chlorine is preferred as a disinfectant. Chlorine carries out disinfection at water treatment plant, and it also takes care of future recontamination. That is why whenever we drink this water that we are getting from municipal supplies, right, this water has some taste, especially the taste of chlorine. And that taste of chlorine is due to this combined residue, which is added intentionally so that this future recontamination can be taken care. Okay. This is known as breakpoint chlorination. A lot of numericals can be formed from this curve. This curve is a very, very important curve, right? Now, this is the fifth type of or sixth type of chlorination. The last type of chlorination is superchlorination. The sixth type of chlorination or the last type of chlorination is superchlorination. The last type of chlorination is superchlorination. The last type of chlorination is superchlorination. Now, this superchlorination is done only during the pandemics or epidemics. If there is any disease outbreak happened in a particular region or in a particular country, then during these epidemics or pandemics, intentionally more amount of chlorine is added in water, so that if any artificial or the microorganisms from the remote sources are getting added, those microorganisms can be killed through this added amount of chlorine. So, superchlorination is done during pandemics. It is done during pandemics, or epidemics, where extra amount or extra chlorine dose is added to water. Extra chlorine dose is added to water, right? So, these are the different forms of chlorination that we do. We start with plain chlorination or pre-chlorination or post-chlorination or double chlorination or breakpoint chlorination or superchlorination. In normal working conditions, we go with the breakpoint chlorination, right? Especially in rainy season when the impurities are more, then we can go with the double chlorination, right? But most part of the year we go with the breakpoint chlorination. My dear students, this topic is very, very important, especially this breakpoint curve. You need to know every part, what is happening in every stage, and how chlorine is reacting with the inorganic compounds, organic compounds, and the microorganisms, right? So, I have tried my best to explain you this chlorination or the topic of disinfection, which is again one of the very hot areas from where a lot of multiple select question, numerical answer type question and MCQs can be framed from environmental engineering. When you see these GATE previous year questions, you will find that many questions are framed from the Chick's law and many questions are framed from this curve, which is the breakpoint curve, right? So I hope you have found this session useful, you have found this session informative. Please join our Telegram channel for daily quizzes, for updates regarding our YouTube sessions. We are regularly conducting these YouTube sessions which are conducted for most excellent questions and the most expected concepts that are asked in GATE examination. We at IMS GATE Academy throughout the year conducts these YouTube sessions to help you to understand topic in a very short span. And till GATE examination, we promise you to deliver the entire content in a very limited time. So this is all from my side, myself Prateek Mishra, and I'll sign off today and I'll see you in the next session with a very, very important topic of wastewater quality parameters, that is biochemical oxygen demand. Till then, take care and have a very good night. Thank you so much.